live. Just need to check the last things. Okay. Hello, everyone. Thank you for joining us. We have a very special guest today. So for those who are the first time with us, we are PyLadies Amsterdam, and today all teams is here. So me, Eleona, Julia, and Nancy. So we're all here to support during the event. We are PyLadies Amsterdam. We are part of global nonprofit PyLadies with our core idea to make sure that we're not just talking about tech, but we are doing it, and we're making sure that the people who are not heard enough are being heard. We do it basically by running monthly workshops on different topics. It could be introduction or it could be deep dives into something. We're mostly focusing on giving the space and podium to underrepresented groups. Sometimes we do exceptions for people who really are allies and who support us. And I would say today would be this case. So if you're first time with us as well, basically, for this workshop, we're going to start from the blank page, which is also really exciting and interesting. And at the end, we end up with materials that will be literally stored for you at the GitHub repository. This event is also recorded right now, streamed and recorded after, which means that when the event ends, you still have an opportunity to get back, to rewatch, to get back to materials, and basically cover anything if you didn't have time to do that. So for now, I will give the space to the Vincent. I guess Vincent can introduce himself, right? Yeah, the floor is yours.
Thanks. Yeah, I guess I can introduce myself as well. But let's first make sure the audio visual setup is pretty good. So I will hit the share screen button. I will hit desktop 1, and that should share the screen I've got down below here. So one thing I would like to quickly check is if I can, people can see me doodle here, like people can see me write the word hello. People can just nod. Okay, great. The whole audio video setup is working. Great. So hi, everyone. My name is Vincent. People might have heard of me because of some of my PyData talks, because those tend to be somewhat popular. I also have some antics on Twitter. But in short, I've been like a data person for the last 10 years, and I do a bunch of education and volunteer work. PyData Amsterdam was a thing I helped co-found back in the day. I do this thing called Calm Code. I do a whole bunch of open source projects. But the reason why we're here today is related to this NLP tool called spaCy. Up until recently, I worked at this company called Explosion, which is the company behind spaCy. And I think spaCy, even though we've got LLMs and stuff these days, I still think that spaCy is kind of a neat tool. So what I figured might be fun is that I would just start with a blank slate, just kind of explain how spaCy roughly works, and basically open up the floor for all sorts of questions. And then I can also kind of talk about how you might want to do NLP projects in general. And maybe if there's time at the end, we can talk about how spaCy compares to LLMs these days. Because even though LLMs are like really impressive, there's definitely still a very easy to demonstrate space for spaCy in NLP, I would argue. So one thing that might be kind of nice and good, like I do want to maybe, yeah, okay, see a bunch of people sort of join in, so I think we can just go ahead and get started, and people are also watching in via YouTube probably. But okay, what I'm just going to go ahead and do right now is just give you the brief rundown of what spaCy kind of does. So I'm inside of a Jupyter notebook here, and you can see that I've imported this one little library called spaCy. Fun fact, the reason why it's called spaCy is because of the word space. Like we're going to split tokens of text, and usually you have like a space between them. So that's where it sort of comes from. But also the inside of spaCy is built with something called Cython, which is a very fast variant of Python that's kind of C-like. So, and that, like the original version of spaCy really does fast tokenization. That's like the base thing that it does. So I would like to give a quick example of that. So what you can do inside of spaCy, you can import it, and then you can say, give me a blank English pipeline. This will then give you an NLP object that you can use for all sorts of NLP tasks. So one thing I could go ahead and do is I could say, well, let's give it some text. So my name is Vincent dot, right? And then text goes in, and out comes something that's known as a document, which is an object with some structure in it. In particular, like one thing that you can do is you can say, like, just give me all the tokens in the text that we just saw. So for each token in that document, the thinking is that this document is an iterable that you can iterate over, right? So I can show the token real quick. And you can see that without doing much else, just text going in, spaCy can do tokenization. So it's able to split the text up into like these little tokens that represent some sort of meaning, you could say. But one thing I want to get at right away is that there might be this misconception that tokenization is just splitting it up by the space, and that's actually not necessarily true. Just as one simple example, like you can read, my name is Vincent, dot, but that dot is actually punctuation, and you could argue that that's maybe a separate token in a sentence. And you can also see that technically there is no space between Vincent and this one little dot. So that's already some intelligence that spaCy can kind of do on your behalf. It's not just splitting by the space in a sentence, it is also doing something extra on your behalf. And this sort of thing gets even more interesting when I do stuff like this. Like if I were to have a sentence that says, my name isn't Vincent. I'm going to run this in a bit, but it might also be like a nice moment in time to sort of think for yourself, like what would we expect to happen here? Like if I have a sentence like my name isn't Vincent, and if you were to sort of split it up into tokens that each kind of have a meaning, like what would be a reasonable way to go about this? I'm going to give you like a good 10 seconds to maybe think about it. And hopefully it's clear that this is the most interesting word when it comes to tokenization in this sentence, but just to sort of think about what we might do here. Well, what spaCy does, and I can argue that it's kind of reasonable, is that it takes is separate from nt. And that might surprise you initially because you might think, well, it might be easier to split on this character over here. But certainly here you can see the spaCy is actually doing something intelligent. There are these internal rules, kind of like heuristics on how you're supposed to split text. And if I were thinking about the meaning and also kind of how the English language works, you could argue that maybe this is pretty much the same sentence. Like isn't is the same as saying is not. It's kind of just more of an abbreviation. And as far as meaning goes, it makes sense that the negation part is actually tokenized, maybe. And that's actually what's happening here. Like is sort of very much telling you something about the verb, and this nt is really telling you something about negation that's happening in the sentence. So that is why I think it's kind of reasonable that if you were to have a sentence like isn't, that then this will be split from is. But all of this here is just to very briefly show you that from the get-go, this is kind of the linguistic stuff that spaCy can do on your behalf. There's just a couple of pre-trained language models and some sensible heuristics that can really go and do this sort of thing pretty well. And the interesting thing is, like, we have these tokenization rules for English, but we have them for a whole bunch of languages. And that's also where some of this stuff starts to matter. My Chinese friends have told me that the Chinese language support in spaCy isn't necessarily the best. The main authors of spaCy don't speak Chinese, but you can imagine, hopefully, that for a language like Chinese, the way that you split up all these characters isn't super simple. We just split by white space. Like different languages have different demands when it comes to tokens. But for English, life is still relatively easy. But the main thing I hope to get across, at least for now, is that we are dealing with an NLP pipeline. The whole point is that text can kind of just go in. And my screen is sort of freezing. Oh.
You mean the screen that you see, or I see that you draw in a doodle?
Yeah, but I'm actually trying not to doodle anymore. Hang on, I think this might be maybe after.
Okay.
Okay, so that feels, I guess, a bit better. Okay, I can't doodle anymore, but I'll take it from here without the doodle app. But anyway, the main thing I hope at least is that it's pretty clear that we have something of an NLP pipeline that spaCy can give you. And either this is a pipeline that's something that you've made yourself, you've trained it on your own data, or it's something that spaCy just provides from the get-go. And this is just an example where I'm showing off that it can do something like tokenization, but there's a whole bunch of stuff that spaCy can do under the hood. What I will just check is if is it possible for me to like switch the colors, and can I maybe then draw? No, that's just really broken. Okay, we'll worry about that later. But I hope that I can also show stuff working here.
Yeah, but at least when you highlight it, we see then you highlight it. So
Yeah, it's just one of those things where like buy the expensive Wacom tablet, Vincent. It'll be fun, they said.
indeed,
It'll be great. It'll be great, they said. Spend the $100. Anyway, so this drawing app has been broken ever since. Having said that, I'm sure we can manage, but this is like the base example. Are there any questions at this point in time? Because I'm going to be sort of expanding and expanding on this, and I do think this is like an interesting first demo already. So just to gauge the audience. I can't see the chat, by the way, but like people can.
You don't need to, so just in case something pops up. But basically, people can unmute themselves and ask the questions if they have any of them.
I have a question, but I don't know if it's fair because I'm co-organizer. But
Go ahead.
Maybe you will cover it later. But it's maybe still used, right? We do tokenization, if that's the right pronunciation, for LLMs and such, right? So.
Oh yeah, so definitely true. It's just that the way that the LLMs do tokenization is a little bit different than the way spaCy does it, and it's actually kind of interesting to maybe talk about that.
Okay, nice.
Yeah, no, that's a good question. It's just that now I gotta grab my what's the name of the app? Pixelmator? No, I had like a. Didn't I have like a better drawing brush thing? We'll go with Pixelmator. Fine. New Pixelmator. Well, let's go for the big one and let's move that down here. Hopefully I can still draw on this. Let's grab the brush and is it okay? I can okay, we're gonna use a text editor instead. So let's talk a little bit about text. So suppose I've got a word like geology, right? Or geography, or geologist. Like these are all professions and stuff. So one thing I can do now is I can think about the meaning of these words, and then we can sort of talk about like what are tokens really. So as far as spaCy is concerned, something like geology will be like a single token, and something like geography would also be a single token, just like geologist. But you can kind of imagine that if, if I were a large language model and I really have to do all the different languages out there, then you can imagine that the number of tokens just really start to pile up. Like you're going to get so many different tokens that you might need to keep in your vocabulary, so to say. So what LLMs typically do, and transformer models do this as well, like BERT also kind of does this, but BERT internally, they kind of do this trick where on the inside, a pre-processing step is happening and they're kind of splitting these words up. So I might have something like geology, geography, and geologist. And you can imagine that you can do some clever pre-processing with a compression trick such that, maybe this first part of the word happens so often that we can deal with subtokens and use that in a system instead. And that's kind of a subtle difference. As far as I'm aware, spaCy really tries to have tokens that are kind of more like words, but the tokens that these LLMs use internally tend to be more subtokens. They like a single token doesn't necessarily imply it's a single word. That's a subtle difference, but like when you're talking about tokens in LLM land, that's usually the subtle difference that makes it hard to compare to what spaCy does. And that's, I think, important enough to mention explicitly.
Right. So the methodology would be totally different.
I mean, it's not so yes and no. It's not totally different because you're still dealing with a token. And if we're talking about neural network architectures, the token still gets fed in and gets processed and all that.
But like the way to find it is really different.
Yeah. The definition of a token can vary depending on what you're doing exactly. That said, I might show this in a bit, but spaCy can use BERT models under the hood that do use their subtokenization tricks. But then to you, the user, we're still going to talk about tokens as if they're more like words or concepts at least. But yes, there are lots of tokenization techniques. As far as spaCy is concerned, though, they are really similar to words. Just be aware that you do have some of this isn't stuff and this punctuation that's not exactly a word, but you can hopefully imagine that that's also still useful to have that separated from the sentence. Does this answer and cover your question?
Yeah, thank you.
Perfect. We'll move on to the next bit. So, okay, we can use tokens, and having tokens is nice. It's not bad, but you are usually interested in more stuff. So what I'm just going to go ahead and do is I'm just going to go to the spaCy website, And I'm just going to have a look at the models that they've got. So, okay, you can go to usage, but in this case, I'm just going to go straight to models. And you can go here, you can see a whole bunch of languages that have trained quote unquote pipelines. So there's one for Dutch. And for each of these, like this is the name, and there's like a little model card below here. They basically tell you what components are in here. They also tell you when something's not in here, but they also tell you what data set it was trained on. So in case you're interested in knowing more about a model, you can definitely sort of zoom in here and sort of know more about the data set and stuff. In general, I think it's safe to assume that spaCy models have been trained on data sets with relatively good spelling. So you can imagine that there are these old newspaper articles, let's say, and there's information there that we can train on. But it's also good to keep that in the back of your mind, because if you're interested in using spaCy on, let's say, social media text, where there's lots of spelling errors and like internet jargon, so to say, then those might be things that spaCy has a bad time with, and then like keep that in mind. But just for demo purposes, I'll just go to English because I'm assuming most of us speak English. And I think we can kind of go for the medium model. That feels kind of like a fun one. So the medium model does tokenization, but it also does grammar and stuff. So let's now say that I've convinced myself that I want to go ahead and use this medium model. And we'll go back to the notebook and we're going to talk about how to maybe do that. All right. So I'm gonna need to install that model. And typically you would do that from the terminal, but you can also do that from the notebook as long as you use this exclamation mark at the beginning. That's going to tell the notebook to run it as if it's like a bash prompt. And I could go ahead and tell spaCy to download this English model locally. The medium model is not necessarily super huge. It's like 42 megabytes or something. If you were to download the large model, you do get into the hundreds of megabytes pretty quickly, maybe even 900. I could be wrong. We can check. But the medium model is like a pretty safe bet if you're interested in keeping things relatively lightweight. So at this point, I'm just going to restart the notebook for good measure. I don't think you really have to. But the nice thing is that right now, I downloaded the new model and I can tell spaCy to load that new model. And this is now a pipeline that, it does tokenization. It's like a thing it totally does, but it also does some other stuff. And I think it might be interesting to show some of that other stuff. So I have a token over here, like that's a remnant from this for loop. So the last token from this for loop, that's something I can access. And like one thing that's always just kind of fun is to call dir, dir over a Python object. And then you can kind of see all the properties that are available on it. And that's kind of like a very like simple way to just explore what you can do. So, okay, if I look at that token, there's a bunch of dunder methods, let's ignore those for now. But I can notice that, hey, there's something called dependency and ancestors and entity types and is alphanumeric and is digit and is punctuation and language, and there's all sorts of properties that are attached on this thing. So let's maybe print that. So I think if I recall correctly, part of speech is something like this. So I'm going to print the token, but I'm also going to print some extra information now. So part of speech. Let's do that, right? All right. So each token, it definitely has text, but then I also get some part of speech information, which will tell me, oh, there's like an auxiliary verb here, or like a noun, or like a proper noun, or punctuation. And that's actually like grammatical information that we can parse out. If you're ever kind of confused by what some of these things mean, by the way, you can always call spaCy.explain. And in this case, I will give it like the aux, because how on earth would you know that that's an auxiliary verb? Okay, the explanation could be a bit better here. Like I would have liked auxiliary verb instead, but still, you can get like a little bit more information from these abbreviations that spaCy sometimes give you. But this is definitely kind of nice, right? Like we can definitely see that this token has some properties attached, and some of those properties might actually be super duper interesting. I'm just going to mention like another fun property, like the doc itself also will have some properties that are interesting in terms of things you might want to detect. I think the entities one is one to maybe mention. And I think I can also get that from the token. Yeah, so I can get like an entity ID out as well. I don't know, it was like something entity, something, oh, entity type was maybe. Yeah, there you go. So this document has entities, and when I call it like this, it will tell me which token is an entity. But if I'm interested in also in just seeing like on that token, what entity type is it, then here you can see that, oh, Vincent is now detected as a person. It's a person entity. And that's also stuff that we can just go ahead and detect. Now, to be a bit formal, that might actually be good. So what is an entity actually? The formal name for it would be NER, which stands for Named Entity Recognition. Like that's the name of the task. And an entity is basically just a substring in text that belongs to a certain type. Very often it's a name of something. So it could be a name of a person, could be the name of an organization, it could be the name of a company. There's all sorts of entities that you could detect. Another type of entity could be the name of a place or a reference to a monetary value. Like these are things that are typically detected, and these are also things that spaCy models have some support for, so to say. So if I were to say something like, hey, my name is not Vincent, maybe it can detect my last name as well. Yep, there we go. Then it's able to detect that both Vincent and Warmerdam, those two tokens are part of a person entity. And when I ask for all the entities, spaCy is able to say that Vincent and Warmerdam together belong to one entity, because that's probably just referring to a single person. Entities inside a spaCy cannot overlap. So a span in a sentence belongs to one and only one entity. You cannot have overlapping entities. And they're always consecutive. That's also something to remember. So you can never have a situation where you've got the term Vincent, then a token that's not part of the person entity, and then you've got Vincent's last name. Like it has to be completely consecutive in order for it to be a named entity, so to say. So these are some of the things that spaCy models just out of the box kind of give you. And there are some things that might be good to discuss at this point, but it's also good to maybe check if there's any questions before I move on. Radio silence, so I'm assuming there's no questions.
There is one in the chat. Can you see the chat?
Oh, I will.
On Zoom?
Oh yeah, there's a button there that I can
Oh,
click.
that was really, really nice one. Yeah. So it's a button called chat. If you go,
I find it. Good. Oh, if I could try out some gibberish. Yes, that's a great idea, by the way. So what's being suggested right now is to just try out some sentences and stuff, and that's something you should totally do. It's always a great idea when you're dealing with a pre-trained model to poke around and see if you can break it. So the question is, if I could add, my name is not VW, but A, B, C, D, E, F, G, H. All right, so in this case, it doesn't detect names at all. However, if I were to do something like Vincent W and then full stop, then the W is detected as part of a name. But I could also do, I'll just make the sentence a bit shorter. But if I really want to do some good tomfoolery here, notice, by the way, that W and then dot is now part of this token. Like it's not a punctuation mark. It seems to understand that W is being abbreviated here. But we can play around a little bit with capitalization. That is a fill. Oh, it seems to detect it kind of all right here, but let's go with Vincent Warmerdam. Maybe that's like a, yeah, there we go. Now it's being, it really has no idea what to do now. Okay, so Vincent Warmerdam is not a name. And I can definitely imagine that the name Vincent would have appeared in a data set that spaCy was trained on. One thing that might be fun to do is if I change this to Warmerdam, it's still not taking it. But what if I change this capital letter? Okay, then it thinks it's an organization. That's also pretty interesting. And what if I change this into W, capital letter? Yeah, okay, then it has a hard time. But this is a really good exercise. I don't want to suggest that spaCy models are perfect. They are totally not. The thing is that they are trained on specific data sets that seem like data sets are relatively big and they do seem relatively general, such as a pre-trained spaCy model could be relatively useful to a lot of people. But especially if you start giving it names that it simply has never seen before, or if you're dealing with names that aren't spelled correctly because there's no capitalization, then this is definitely something that could go wrong. And I can also imagine that something that is capitalized but isn't exactly a person's name, that might be an organization giving the grammatical structure of the sentence. Like that's kind of the reasoning that might be happening in the background here. But the attitude, but the attitude here is like great. Like try to break the model. Like always do that. Also with Hugging Face models or LLMs, just see if you can break it to understand where the model has a failure scenario. That was a question?
Yes, I guess someone's tried to ask something, but in the meantime, there was like this continuation to the previous question.
Yeah,
So
the doc test.
gibberish. Yeah.
So let's do the gibberish one more time and then see what comes out. But my name is not VW. It is something like that. Some gibberish, right? Oh, I need to close that string. So in this case, there will be no entity. So this is going to return an empty tuple. And again, I hope the reasoning is like pretty clear on that because no entity was detected here whatsoever. So then it's also making sense that the document itself will not contain any entities. Cool.
Yeah, I think I see the person they're trying to rejoin. So just in case this person is back, they can always ask their question. So I think we can continue. Thanks.
Sweet. So okay, like this is pretty cool, right? Like we can play around in the notebook a bit. You can sort of for loop over all these different tokens, and then that's all fine. But you can also wonder, like, is this the nicest way to deal with text and to sort of gain insight? It might be nice also to just have a chart at your disposal, and spaCy does cover some ground there as well. So what you can do is you can do from spaCy import displacy. So displacy is basically spaCy's visualization tool, and you can render a document in it. And right out the bat, if you don't provide it with anything else, like the base assumption is that you're interested in the grammatical structure of the sentence, and that is something that it can visualize. So for each token, you can see that we've got a part of speech below. But just like you can have parts of speech that belong to a token, there's also relationships between the tokens. So things like, what is the subject of this verb, so to say? And you kind of need a little bit of background in linguistics. In Dutch, you would say something like, wat is het onderwerp van dit werkwoord? I don't know all the other languages, but for Dutch and English, I know the terms. But that is something we can definitely also visualize and know that this information is also attached to all the different tokens, so you can also access it programmatically. But this is also, I think, a pretty fun way to just have a look at what spaCy provides, also to explore failure scenarios. Like sometimes the visual is a little bit more impactful than like doing the for loop and all of that. I am going to do something just a little bit more fun though. So let's do NLP, open, close bracket, close bracket. So that's all fine, well and good. And I can say something like, hi, my name is Vincent, and sort of run that. It's a nice little short sentence, and this is fine. But the reason why I want to show this is because there are also different options in terms of rendering. So what I think I should be able to do is I can say the style is for entities or ent maybe. That's a type. Did I misremember? I think it was something like, yeah, there we go. So you can also give it like big swaths of text, and it will write the bit in a sentence that is a person. So if you're interested in entities, like, hi, my name is Vincent, I have a few pets in my house, and my house is in Haarlem, which is in the Netherlands, something like that. Then you can just kind of see that, like, as far as the visual goes, you get a nice visual confirmation which entities have been detected. So Haarlem, that is a GPE. And what is a GPE actually? Well, let's just ask spaCy explain to give that GPE, typo. Those are countries, cities, and states. I don't know, but it feels a bit weird that GPE is the abbreviation for that, but I'll take it. These are places, basically. And yeah, there's like a final like thing I can do, Vincent. Warmerdam here, and you can also confirm here that like Vincent Warmerdam, those are two tokens that both belong to the same entity. And I do see like Scott M. Scott Marshall is giving a very good comment here. Yeah, GPE stands for geopolitical entity. So I think geopolitical entity, like that does sound like the abbreviation, but I'm just kind of curious why, if you call spaCy explain on that, why it wouldn't say geopolitical entity. But I can imagine that maybe to a layman, countries, cities, and states is probably like a better definition, actually. So okay, fine. That does actually make sense. All well and good. So this was just a very brief demo of displacy. Displacy is kind of nice. There's a bunch of things in there that can do visualizations for you, and this is like one of them. Any questions on this at this point in time? I can hear a bird in the background, so that's implying that there's no more extra questions. So that's, I think, fine, well, and good. So we'll move on to like, I suppose, the next topic. So I guess there's like one, like the main properties that we've seen so far that are just kind of useful, like the part of speech and things like the entity type. Like those are sort of all things that are just kind of nice and good. I do want to maybe mention like one use case though that I do think is just kind of nice. Yeah, for that we'll just need to do this. So like the first thing I ever did with spaCy was I tried to detect programming languages in text. So I was dealing with a big data set of, Stack Overflow stuff. And I was just kind of interested in like, can I detect programming languages in the Stack Overflow questions? Because it might be a use case where a question comes in and a user forgets to add a tag. But if we can detect a programming language, then we might be able to automatically add a tag, let's say. Like that was a use case I kind of had that I made up in my mind. And I kind of figured like, that'll be a nice excuse to start using spaCy. Maybe that would yield something that's kind of useful. And then you do kind of wonder, like, okay, but are these tools like part of speech? Like, is that something that's actually useful? We're going to give it a bit of a spin now, but suppose I were to write something like, I want to go and learn Python, right? Oh, that is also interesting. Like Python is being detected as a product here, which okay, that is definitely kind of interesting. But why am I showing you this sentence in particular? Well, it has the word go in it. And the word go is actually kind of interesting because in most cases, in most uses of that, like when you see the word go, 99 out of 100 times, it is a verb. So it is really about like, hey, I'm going somewhere, and that's the thing that's being communicated. But if you are interested in detecting the programming language Go, then you've got the same characters. So you cannot really do string matching because if you're going to do string matching just on the term Go, you're going to be wrong 99% of the time because most of the time, also in the Stack Overflow corpus, it is just totally going to be a verb. And you don't want to detect any of the verbs. But maybe that is actually something that you can turn into a classifier. You can sort of build some domain rules on this where you can kind of say, well, if I ever see the term go and it's not a verb, then given that that sentence came from the Stack Overflow dataset, the odds of it being about the Go programming language, those are actually pretty high, maybe. So that was kind of like the reasoning. And I'm going to try to see if I can actually get spaCy to do that. Well, no guarantees, but like fingers crossed. I really enjoy programming in the Go language. Let's see if that's a language. There we go. Yeah, so go right now is being detected as a proper noun, not as a verb. And spaCy is going to make mistakes here and again, right? But hopefully you can also imagine here that like, oh yeah, like those parts of speech and those like grammatical dependencies, Those are based on statistical models, but assuming that those models are quote unquote not bad, you can actually also do some rule-based system stuff on top of this. And that's just kind of nice sometimes as well, which is something I just wanted to sort of maybe mention up front. Like when I first dove into spaCy, I thought, oh, I'm going to do named entity recognition. But there are these weird moments when you don't always need to go with a custom model in order to detect some things in text that you're interested in. Sometimes knowing whether or not it's a verb is maybe sufficient for what you're doing. That does bring me to like one extra thing I might just want to show. Like if you are dealing with a document inside of spaCy, there's this one method on that called noun chunks. That's just super duper useful. Oh, and that's a generator. Let's turn that into a list. So, yeah, let's actually displacy that thing as well, because it's just kind of a good one to show. Because I'm about to show you a feature that's like all about those rule-based systems. Doc, there we go. Oh, and no entities. I want the other one. There we go. So like sometimes in text, like what we had over here, like the Go language, for all intents and purposes, those are multiple words, but they chunk together as if they're like a single noun. Like grammatically, I could also say, I enjoy programming and then it could have been Python. Like from a grammatical point of view, if the noun chunk is a single word or it's like composed of multiple words, grammatically you're still pointing to like one thing. It's just that that one thing consists of multiple tokens. And the grammar actually sort of helps you confirm that. So you, again, kind of need some linguistics knowledge, and that's not my strongest suit, but you can sort of say, well, there's a certain type of relationship that's happening here. It's like possessive object. And that possessive object points to something. And then we see that there's a determinant and a compound noun. And like, okay, that you could argue that that kind of indicates that the latter part of that sentence is just sort of a chunk together because there's a single arc going out and none of the other arcs go outside of that chunk. So you could actually reuse these grammar rules to find all the noun chunks in a sentence. So much so that spaCy has actually built something for that logic on top of the doc object. So you can also just call the noun chunks and you just get all the different noun chunks in your sentence. Why is this so useful? Well, if you're going to do named entity recognition later, you are going to recognize that 9 times out of 10, the entity that you're interested in is actually a noun chunk. So if you're interested in a reference of a programming language, then you could argue that the Go language, that whole thing actually points to the programming language Go in this case. So if we're going to start labeling and annotating and stuff like that, having something that can just split up text in noun chunks is just incredibly, incredibly useful. So that is also like something I just quickly wanted to demo. Yeah, I think as far as like a basic introduction to spaCy goes, I'm kind of good. Any questions on this so far? I'm also going to have a quick look at the time here. 7:11, so that's like pretty good on time.
I have a question, but again,
Yeah,
I
go
don't
ahead.
want
Go
to
ahead.
like hijack that.
You're not hijacking if you're the only one who's asking a question. That's fine. Go ahead.
So what happens if you change Go to Python? By the way, I'm prompting ChatGPT just out of curiosity on the same things that you're doing to compare.
Okay, so Python in this case is also detected as a noun.
Okay.
Right?
So ChatGPT changes. Yeah, then it says when you put Python, it says adjective. But yeah, I'm not sure why.
Well, I'll go to ChatGPT in a bit because there's some interesting. I can talk a little bit about prompting, I suppose, because there's some interesting stuff that we could do.
Just hold on. I'm just curious. So, okay, it's recognized as a noun, which is correct because Python by default it's a noun. But how it's gonna take a look at it as a noun chunks? So whether it's gonna recognize it as now I see it's still recognize it as a one noun chunk, which is
Yes,
the Python language.
but
Oh, that's great.
Yeah, so the part of speech tag is one part of that equation. Let's talk about this some more. So these are all sorts of grammatical dependencies. So things like, okay, what's the subject of this verb, and when is something possessive, and that kind of stuff. Now you can see here that okay, we've got a verb, and that's pointing to something. That's again pointing to something. But at some point, we see that there's an arc going into a subtree, right? This graph structure is kind of like a graph, and the type here is possessive object. It's pointing to a noun, and all the parts of speech that sort of belong to the cluster in here, those are either nouns, possessive proper nouns, or determinants. Then it's probably a noun chunk. Like that's the reasoning, so to say. It's not just the fact that there are nouns being detected, it's also that there are grammatical dependencies being detected between the tokens. And when you combine those two things, you can kind of build a rule-based system that just kind of says, well, there's an arc going in, and there's no arc from here that's going out to like a previous part of the sentence. Oh, and all the parts of speech sort of map out correctly. This is probably a noun chunk. Like that's the logic that's happening here. So you don't just knowing the part of speech is not enough. You need to know these grammatical dependencies, I guess. So that's the formal word. Was that sufficient for an answer, or is there still confusion? Okay, so there's one question that I do see coming in. Like, how do you deal with grammar mistakes in spaCy? I don't know. That depends on the use case a lot. But this is the general question of how do you deal with pre-trained models that make a mistake? The way you deal with it, I think, is you just naturally assume that they will make a mistake once in a while, and you just try to reason about how bad it would be when it makes a mistake, or you try to understand what kind of mistakes are made often. Like understanding the failure scenarios usually helps inform you whether or not using a pre-trained model is a good idea. In particular, spaCy is not necessarily amazing when it comes to social media text. That's just something I've seen over and over and over again, especially if you're dealing with names that aren't capitalized. Like that's like a failure scenario that I've happened that I know is going to happen out there. But then if you're dealing with, I don't know, like newspaper articles or something like that, then part of me would argue, well, unless the newspaper article is about all sorts of politicians that are super new and have never been seen before, that could be a failure scenario maybe because the data sets that spaCy train on are relatively old. But I mean, the United States hasn't changed its name for a while, right? So like it should be able to detect some of those countries at least. And like that's the way I like to reason about it. Sweet. I think that's about it for questions. Am I mistaken, maybe?
No, I think that's it for now. I guess also like they just said thanks for explanation. I also have a question again about the social media text. It usually has a lot of emojis in it.
Yes.
So basically, how spaCy reacts to emojis.
Well, let's find out. Winking face. Let's put you in there. Yeah, so I recall I actually vaguely recall an effort a few years ago to have like a pre-trained model in spaCy only for emojis. That was like one of the hobby projects that Ines did. It's been a while, don't know for sure. But as far as text goes, it is detected as a token, so that's definitely good. The stuff that follows though, for sure, I would not be surprised if it makes tons of mistakes here. And actually, like one thing, like what would happen if I have like an emoji for a computer? Yeah, so like woman technologist, let's go for that. And like if I put the woman technologist instead of a verb there, would it still detect a verb? Nah, like this. Oh, that's also kind of interesting. Like the woman and laptop together. Yeah, that's also because emojis, sometimes you can build emojis on top of other emojis. But anyway, like fair enough. You can see that it starts making mistakes here, and this is really good to point out. This is also a failure scenario. I would not be that surprised if ChatGPT also has a few issues with this. But yeah, like this is also the reason why at some point you might want to train your own spaCy model. That's also something to kind of keep in the back of your mind.
Okay, thanks. The reason why I actually asked about emojis is because it was basically the task on sentiment analysis, where there was an idea to see whether we can get any meaningful understanding of, like the reviews that we were given based on not just text but also on emojis. But that was pretty difficult to execute, I would say.
I mean, so one thing that, as far as like, there's a few things that are like the bane of my existence when I do NLP stuff. And when it comes to emojis and social media text, like the main thing I remember that just was always breaking me was sarcasm. So, okay, if someone has like the rolling eyeball emoji next to a sentence, basically that's an implication that someone might be sarcastic. Oh, so that basically means you have to negate the meaning of everything that was happening before. But like, how do you teach a spaCy model that rolling eyeball emoji is negation on whatever was said before? Like, that's kind of hard. Another thing that's also just kind of interesting, like because we have the internet, language is also just super different. So I would really argue that maybe internet English is different than like normal English, and that's because of stuff like this. So if someone were to say that they really enjoy programming, right? Like they put stars around the word really. Like that also messes spaCy up because spaCy has never seen this kind of language before in newspapers. But I would honestly argue that some like stuff like this will happen on Reddit and social media text all over the place. There's also, if you're interested in this, by the way, there is a book from a linguist. I forget the name, but the name of the book is Because Internet. And the book is really just about how many different ways the English language has just changed because of the internet. And part of it is really stuff like this. Now, there are things that you can do, like you can maybe annotate some of this data and sort of pre-train something fresh. But the main point I want to drive home here is that while these spaCy models are pre-trained, nice and useful, they are just not perfect, and that is something to always keep in the back of your mind. Gretchen, yes, that's the name. Thanks for doing the Google there. A pretty good book, by the way. If you're kind of like a language nerd, you'll find stuff to like there. Definitely. Like I've read parts. Like I didn't read the full book because I was busy. I remember, but like I'm dyslexic, and I really like reading that book. Is what I'll say. Stuff to like. But okay. Maybe what will be fun now, and I do think that's like a fair statement to maybe zoom in on, right? So okay, we've got spaCy models, and that's cool, and people can train their own spaCy model. Kind of what else is there? And I kind of just want to briefly show you to this thing called the spaCy universe. And can I maybe get like a normal zoom here? It seems that I can. So spaCy comes with a bunch of plugins that you might be interested in. And some of these plugins include like completely from scratch trained pipelines and something that you might be interested in. So if I recall correctly, we had one. Yeah, so there's a spaCy pipeline for Latin that's like made by a community member. So people have been training spaCy models on a language that's not really being spoken that much anymore. If I recall correctly, yeah, there are legal texts that people have pre-trained their models on. I think one was called Blackstone. There are also models that do like kind of the same thing, but for like biomedical information and stuff. So, you know, there's all sorts of things to explore. But I think the big one these days is this thing called ChatGPT, because you can do stuff these days with these LLMs that might make you wonder, well, do I really need to use spaCy? And it's a fair question that I would just like to kind of go into. So I'm going to log into my personal account in ChatGPT. Let's move that one on the side for now. Let's kind of just zoom in. So let's maybe now do something like, here's text, right? Oh, hang on, I need to, here is text, like that, and then I have to press N. I'm gonna write the prompt in Sublime Text. Here is a text, colon, pretty brackets around it to make really sure that it's being picked up as text, and I will write something like, hi there, my name is Vincent. You know, I can write something like that, and I can ask ChatGPT, give me all the entities from this text. All right, that's something I can do. So I will just go ahead and select the whole thing, copy paste, and yeah, let's make a new chat, and I will just give this a ChatGPT. Okay, and it says here like the entity from the text is Vincent, person's name. So you can kind of look at this and kind of go, well, ChatGPT can do this. Why would we ever need spaCy? Isn't spaCy like super old now? And there are like a few things that I would use as a counter argument. So for starters, right, it's great that ChatGPT can give me this text and it can find Vincent in here. That's well and good. But typically I'm giving a system text, and then usually I'm not interested in getting text back out. Usually what I want is structured information to come out. So maybe something in like JSON or a list or something that tells me that Vincent is like a thing that's being detected. And you can kind of get there, but you are going to have to do some prompt engineering. So I need to maybe do stuff like give the output in a JSON list with dictionaries that give the text and the label name. Okay, so let's try that again. Like maybe now I'm going to get proper JSON out. All right, so it's able to give me proper JSON. That's all pretty good. But let's now see if I can give it a more complex sentence. So my name is Vincent. His name is Barry, and his cat is Noah, something like that. Okay, so it now says that there's like a label person and a label person, and Noah is now a label animal. And I kind of wonder, well, okay, but maybe I'm not interested in detecting animals, right? Oh, and then maybe I could post-process that, but oh, now we kind of get into the topic that I want to have very clear and well-defined definitions of what an entity is. So, okay. What I could do is I could say, well, give me all the entities from this text, give me all the person names entities from this text.
I said grammatical parts in the
Oh,
prompt.
that's also something we can do, right? But like one thing I do want to maybe point out here is that ChatGPT is not necessarily a free lunch. You are typically going to have to do some form of prompt engineering here, right? That's hopefully hopefully that's like somewhat clear. Another kind of issue here is like a timing issue. So let's say that I'm going to put this in spaCy right now, and you know, this is like a single example, right? But I'm just going to time this. Running a single example, and this is with lots and lots of overhead. And if I have 1,000 examples, I could do all sorts of batching and vectorizing and make it even faster. But this is 33 milliseconds on this one machine. Actually, let's do a fun thing. I'm gonna put all of these texts in a list. So that's in my list, and I'm gonna do that times 100, right? So hopefully people can sort of understand the reasoning here. Let's add in another entry here. So I've got a list over here, like, hi there, my name is Vincent, his name is Barry, and his cat is Noah. Okay, that's a sentence that's going in. This is now a list of 100 texts, right? And what I could do is I could sort of call NLP pipe over all of these texts, and I could turn all of that into these separate documents. So let's just see how long this takes. Okay, so going through 100 of these examples took me like less than a second, basically. And let's maybe up that up to 1,000. That'll take a bit longer, but it shouldn't be like the worst. Okay, about 3 seconds to go through 1,000 examples using spaCy. Imagine that you're writing like a local API that needs to connect to OpenAI and like has to go through all these examples. Yes, OpenAI has batching these days, but I highly doubt that you're going to get like this speed from communicating with like a third-party API. And you've also got local LLMs, and it's definitely cool stuff to play with. But one thing to sort of maybe observe here is that One, you can really train spaCy for a very specific task, and that's still definitely useful. You don't have to send your data to a third party, and most of all, spaCy is just a lightweight thing. And if you're dealing with like millions of documents, that is still going to be super duper valuable. So even though I want to acknowledge that LLMs are just kind of amazing and you should definitely maybe try them out if they fit your use case, there is still going to be this need for something that can just go through all of your text in a very quick fashion without needing a GPU. And when you combine that with the fact that you can really make it specific and tailored to your use case on your own data, it's actually still relevant, I would argue. Like annotating a data set yourself, getting to 1,000 examples might take you a day, but then you do end up with a model that's still reasonably good and really, really fast compared to like all these LLM alternatives. If you care about like CO2 per watt and that kind of stuff, like space is a good bet, is what I'll also say there. Any questions about these remarks? Because I think it's like a relevant thing to maybe mention. Like spaCy to me is definitely still relevant because of this phenomenon. Like LLMs are just also slower. It's just something to really keep in the back of your mind. Even if you have like the most amazing prompt, stuff to keep in mind.
I guess also really important piece here is cost of using it. And also based on which model you're using. If you go with a cheaper version like GPT 3.5 Turbo, it's one story. If you go with version number 4, yeah, it's more powerful, but again, it's all gets to the cost question basically.
Yeah, and it's also true for the prompt, right? Like I could make this prompt better and better, but it typically also means you're making it longer and longer. It doesn't necessarily have to be like 6 times as long or anything like that, but like there's also a little bit of a cost picture there. One thing I do want to mention though, and this was like I was kind of helping out a little bit with this effort when I was there. spaCy is also sort of aware of the fact that these large language models do have stuff to offer. So there is a thing that you could do called spaCy-LLM. The thinking here is that maybe if you just tell spaCy, here's like my label and a label definition, and here's like just a couple of examples of stuff I want to detect, then spaCy can communicate with an LLM on your behalf, and then that LLM will produce text. spaCy can parse the response, and then you're still dealing with like documents and tokens and all of that sort of thing. But the logic is handled by an LLM on your behalf, and that is also something that you can consider. I don't know when the last sort of commits were made on this project, but last time I checked, they had a whole lot of vendors. Like, yeah, if I go to the models section, so GPT is out there, but there are also some open source ones. So we've got Mistral, Falcon, Llama, Dolly. So you can also use this against some local running models. It's also something I can maybe recommend. So if you're interested in using LLMs, but you don't want to go through the whole prompt engineering process, this spaCy LLM thing might also just be a thing to keep in the back of your mind. That's also definitely an option. We'll check the time one more time. Good, we're at 8:30. Any questions on this?
I have a question regarding the, so you mentioned that, well, the speed for like a basic pre-trained spaCy model is much better than LLMs. And then is that still the case if we sort of train our own spaCy model? Like,
in the most general sense, yes. Now, what you can do is you can go overboard with the hyperparameters, add all sorts of layers, and really go nuts, right? I'm sure you're going to be able to nullify the claim if you're going to go down that route. But in general, yeah, spaCy is optimized with Python to be fast on a CPU. So that is what it's designed for, I will say. And I would be highly surprised if we ever get like a big transformer model to generate text that's quicker than just doing a convolutional trick, which is what spaCy is doing under the hood.
okay, thanks.
Unless there's like a big innovation in hardware or something like that, where GPUs are now just way cheaper, more lightweight than CPUs, I don't think that this claim will ever change. But again, like there are also reasons to maybe go for an LLM. A lot of stuff is possible, but the main claim I want to make is you should look at spaCy as kind of like the general pipeline for a lot of open source tasks There are also other libraries, right? There's Hugging Face. Go definitely check that out if that's interesting. But the one thing that I kind of like about spaCy is kind of like the same feeling I get with scikit-learn. It is boring in a good way. Like it just implements the pipeline and it gives you like some sensible defaults and you can just sort of run with it. And it is optimized for keeping things lightweight in your machine as well. And that's just cool and useful.
I think just like a quick remark. So basically, when you have one specific task to execute, that's exactly when spaCy really shines. So if you only focused on NER, name entity recognition, or if you're focusing on sentiment analysis on, it's really good. If you, let's say, don't have a lot of folks available to develop something, and if you need something that expect to execute multi-myriad of tasks at the same time, that's probably when this big, let's say, LLMs models could work. But again, it's really, really specific to your use case.
Could you depend like myriad of use cases? Because I could look at spaCy and say, oh, it has all sorts of entities. It has geopolitical places and it has person names. And like in a way, that's also like multitask. You could argue, right? So what would be, well, like what direction are you thinking?
I was thinking, like the whole bench. So you get text, you need summarization, you need some sentiment analysis,
right.
name entity recognition, you need translation, you need. So basically, if you need all of this with one, then it's probably the way to go. Otherwise, you just have very specific, suitable, let's say, separate models which you can use with spaCy, basically.
Yeah, I mean, there's a small clarification we can do there. So you mentioned summarization. Like I would argue that's like a generative task. Like you generate text as part of it. That is something that spaCy is just never going to do. Like it was never really designed for that. spaCy is a detection library. So text goes in and structured information is detected inside of it. That's sort of the design. Now people might write plugins such that you can also get a summary out if you really ask it for. But the core library is all about detection. That's also a way to think about it.
Thanks.
So yeah, I'm kind of wondering what might also be just kind of fun and good to show. Yeah, so yeah, that might be a fun thing to just briefly show, right? So let's now talk a little bit about like, okay, suppose that you're convinced you might want to play with spaCy, you think it's cool. How would you use it? Well, one thing I do like doing is just kind of abuse some of quote unquote abuse, of course, but like I would like to maybe abuse pre-existing models. And here's kind of what I mean by that. So I'm going to give it some text. Pardon, I am going to totally remove this bit. Okay, so we've got, this is a document, right? So I should be able to call displacy. Actually, maybe just use the displacy below. Yeah, there we go. Yeah, so the style equals ent, I think was the thing we got to do there. And then here we should write something like NLP open bracket, and we could put text in here. So I don't know, let's write something like, I really enjoy using fast API, but for a proper web app, maybe something like Django is better because it comes with a big ORM point. Okay. So, what I'm doing now is I'm just giving it data that it really cannot have seen before. Like fast API was not around when the data set that spaCy uses was. But if I'm interested in detecting programming tools, right? Maybe the way that people sort of talk about a tool, like, oh, I'm using this to accomplish that. That's not unlike how people would describe a product. Like if I think about like old commercials in the 90s, then people would say like, oh, I love using this wrench in order to sort of fix my car, so buy this wrench. But if you replace car with programming task, and if you replace wrench with whatever programming tool, the grammatical structure is actually pretty similar. So it's maybe not that surprising that fast API is detected as a product here. And we also see here that Django is being picked up as a person. Now, Django could also be a name of a person. There are people called Django. If I were to maybe replace that with, I don't know, Flask maybe? Oh, Flask. Okay, then it's detected as an org. So, okay, like the type of entity that it's detecting is not 100% in line with my use case, maybe if I'm interested in detecting programming tools. But like one thing that does come to mind when I look at this is go, hang on. But just the fact that spaCy is detecting something, that is also knowledge. So you can imagine, I was building this course for the Talk Python people, and Talk Python has a podcast, and the podcast has these transcripts. And I thought it would be fun to see if I can find Python tools being mentioned in those transcripts. And one of the things I just kind of noticed was that whenever I'm detecting fast API, or so whenever I'm detecting like an entity from spaCy in that text, like sometimes people are referring to people in transcripts of Python, but 9 times out of 10, if any entity is being detected in there, it is probably about a programming tool. And that was actually super helpful because I could do stuff like, okay, write a little script that basically says if I detect any entity from spaCy whatsoever that's not a person, then I could pre-highlight that and kind of say, well, this might be an entity. And then I could give that to like a labeling tool. Prodigy is one I'll show in a bit. And then instead of having to highlight every single reference to a programming language, I would just be able to say, oh, yes or no, as in, yes, the assumption here is correct, or no, it's not there. And that really speeds up annotation if you think about it. And I can give a small little demo of that. Prodigy. So this is the labeling tool from the makers of Explosion, and I could go to the live demo. This is the labeling interface that they've got for named entities, right? So, oh, I need training data for my algorithm. You can kind of like, highlight and sort of remove stuff here. But if I have a document here that's already pre-highlighted, and the only thing I got to do is say, oh yeah, that's accurate, or no, that's not, that is way faster for me as a person to annotate. And maybe that's also the way to think about spaCy. spaCy can also help you get the training data you need to actually train your own machine learning model. It doesn't even have to be spaCy. But like that's also kind of a really strong use case for pre-trained language models, so to say. Like they don't necessarily have to have the labels that you're interested in. You can also sort of shoehorn them to sort of see what they can make from your use case and just get that little signal to start training your own thing. I hope that sort of also feels like a cool use case, so to say. So you can definitely reuse spaCy models on use cases that it has a hard time detecting anything that's relevant. But just the fact that it detects a entity, that is usually stuff you could build on top of as well. Any questions on this observation? Then I guess not. Right. Then I guess like a final thing that I do want to show, which I think is just kind of cool technology, and like it's something that I do think has a bit of a future. So we've talked about maybe spaCy being on one end of the spectrum, and we've talked about like maybe ChatGPT being on the other end of the spectrum. So we've got like super fast local trained model built for speed, maybe not the best accuracy or something like that, but is like meant to be pragmatic and fast. And on the other end of the spectrum, we've got bazillion GPUs to generate text that really have a lot of context and hopefully can also do classification for you, let's say. And it's kind of like a spectrum of models that you might be able to imagine that sit between there. So like not everything has to be the way OpenAI does it, and not everything has to be super lightweight. There's also something in the middle. And there's this really cool project called GLiNER that I do kind of just want to give a demo of. It's also not perfect, but it is pretty cool in what it does. So I'm just going to copy the code because I think that's the easiest way to show. So I'm just going to copy this bit and then dunk it in the notebook, and then we'll see what it does. But the way to think about it is that instead of having a LLM take your prompt and then take your sentence and do stuff with it, Another thing you can also just do is just tell an LLM, look, here's just LLM, you are only going to be doing NER classification, or named entity recognition. So you're not going to have to generate all the internet or anything like that. I'm going to pre-train you to be just like an LLM, but you're only allowed to do named entity recognition. And when you think about all the text that it then needs to generate, there's way less that it needs to concern itself with. So you could actually build like a Hugging Face kind of a model that's way smaller than whatever OpenAI is going to do. But it does give you the flexibility where you're able to say, well, here's just a couple of names of labels, go take it from there. And this is also a model that just runs locally. And I kind of just want to give a quick demo of this. This is not exactly about spaCy, but I do think it's like a related tool that's pretty cool. So I'm just going to quickly install this GLiNER thing. It should be done relatively quickly. Yeah, it's going to install, yada, yada. Oh, didn't have SciPy installed. Okay, fine. GenSim, okay, this is going to be installing stuff. I'll go over the syntax for now then, as this thing is installing. So the way it would work is you would have to sort of point to a pre-trained model somewhere. This will point to like a Hugging Face repository. Then you can give it some text. And here, like they gave it some text where there's a long name and there's like a date in there and there's like references to countries and football and etc. And then this is the text we're going to go ahead and parse, but we are able to sort of give some labels up front. So at the time that we're starting a new use case, we can think of the names of the labels that we're interested in. And the whole point of this LLM is that it's able to do named entity recognition stuff with the LLM sort of way of thinking, but it's much smaller, in such a way that it can run locally. So yeah, I think it installed it just now, didn't it? Or is this still running? No, that didn't. This is so GLiNER is now installed. So what it's doing right now, I think it's downloading this model, so that'll take a small while.
If we have a second, maybe can I ask a question?
Yeah, go ahead. Go ahead.
spaCy? Yeah, about something that you said earlier regarding detecting entities that are not represented by consecutive tokens. So I'm thinking about a specific use case where we would want to detect multiple products in a text, let's say, and specifically, let's think about like beverages, for example. I might read online, we sell Coca-Cola regular and zero, for example. Now, in this particular use case, I would want to be able to detect that there are two entities, Coca-Cola regular and zero as two entities.
Yeah.
Do you think that would be possible with spaCy?
Oh, yeah. No, that's the base behavior, totally. But they would be two separate entities, what I'm saying.
Yeah. Okay, but that's clear.
Yeah. Like one thing that because this is taking a bit longer than I was hoping, like one thing I can also maybe just show. So we do also have support for, maybe we should go to the explosion blog, Spancat. Like when I was working there, they did release a new tool. It's been around for a few years, but the tool is called Spancat. Like sometimes you are actually interested in detecting spans of text that are nested. So so like Bank of China is a nice example. So Bank of China is the name of a bank, but China is actually a reference to a country. And maybe we still want to detect China and Bank of China because they're like nested spans in the text, so to say. Now, the named entity recognition tool inside of spaCy does not allow for that, but there was a recognition that something like that might actually be like super useful. So there is a component inside of spaCy that you can train just like you can train named entity recognition. That's called a Spancat component. That stands for span categorization. So if you are interested in doing somewhat more fancy things, and you've got, especially when you're dealing with like spans of text that don't have a super clear start and end, then that is something to also maybe look at. Like this is just like NER, there's like another one of these components that you can use from spaCy. spaCy also has a text classifier. That's also something you could go ahead and use. I'm demonstrating named entity recognition here though, because that's the component that is most well known for. So would you use the GLiNER to detect programming languages in the podcast transcript or spaCy or a combination? So, you know what? Let's just give it for a spin, shall we? So I really like to make web apps with fast API, but really Django is also super sweet. Admin interface for the win, because Django actually has a super sweet interface. And what I should also go ahead and do now is maybe copy this in a separate cell, because you only want to load the model once if you can, right? So model will load now. There's like a heavy operation, and then given a loaded model, let's see what it does. Okay, so because I said admin interface for the win, and win was detected as an award here. Okay, so fair enough, but let's now go with person, and let's go for Python tool. And let's see what it does. Okay, so it's able to take fast API and Django as a Python tool. So that's pretty dang nice, actually. Let's also Ruby on Rails needs to. Let's see what it makes of that. Okay, so Ruby on Rails is a Python tool as far as GLiNER is concerned. It's not really, though, but I also can't really super blame it for making this mistake. So when someone is asking, like, would I use GLiNER to maybe detect entities? Well, I don't trust it blindly, to be honest. But again, this is a really cool technique to help me find training data. What I can go ahead and do is just say, hey, GLiNER, here's a bunch of text, and see if you can detect entities. And then it's a lot easier for me to sort of look at an entity and say, yes or no, you got it right. And in this particular case, you can imagine that I'm able to sort of maybe generate a labeling interface that sort of looks like this. But it has Fast API, Django, Ruby on Rails highlighted, and the only thing I got to do is remove the Ruby on Rails reference, let's say. Like those are the use cases that excite me the most, I would say. Like one thing that is going to happen to GLiNER, by the way, is right now the project only supports you to give like the name of a label. It would be a lot nicer if you can also give context. So you could sort of say, well, a Python tool is a tool that only works in Python. You can like write a little sentence with the actual definition in it. It is a subtlety, but that will improve the accuracy, I think. And I had a little talk with the folks on GitHub, and they are interested in adding that. But again, just like with all these models, also the spaCy pre-trained things, I don't trust them blindly, but I do trust them to be helpful enough to help me get started. And I think that's like also pretty dang good. In the end, machine learning is a bit of a game of curating a data set and then training a model on it to find patterns in it. That is kind of the name of the game most of the time. And yeah, we can simulate text these days, and all that stuff is neat, but all the tools that will help me sort of curate my own data set, those are useful tools. spaCy definitely belongs in that bucket. GLiNER definitely belongs in that bucket. And it depends a bit on your use case and your data set, which model might be best, right? Like maybe for whatever reason, you really care about the 99.9% accuracy. And in that case, maybe a transformer model is better than the lightweight spaCy thing. But it's just that for most of the stuff that I've seen, the spaCy model does work pretty well. And I really like the fact that I don't need a GPU. One thing that's also maybe good to mention here, let's time this baby. Yeah, so this took 300 milliseconds for this one example. Not bad, but you could do 1,000 entity detections in spaCy in the same amount of compute time. So that's also the balance here. There's still definitely between like spaCy and like ChatGPT though. So like that's the reason why I do mention it. I do think it's like a nice halfway point that will just run on your laptop, by the way. So the GLiNER is a cool thing. And also, I might want to show that. But if you go to like the repo, someone actually built a spaCy integration. So I have not talked about that, but spaCy has like a pipeline system where you can add components to a pipeline, and text goes in and it goes through all the pipeline steps. You can actually, yeah, let's copy this actually. You can actually use GLiNER under the hood and still talk to spaCy in the meantime. So, oh, you do have to install GLiNER spaCy. I will do that now because I do think that's a nice demo as well. I did use it the other day. Did install that thing. Yep. Oh, what broke? Okay, there is a bug in it. Unfortunately, it was working the other day. Do know though that if something works in GLiNER, it's relatively easy if you kind of know the internals of spaCy to make a plugin for it, and a community member has. It just seems that in this particular case, there's a bug. I don't, don't want to go too much in it, but it's an active community. People write plugins for stuff all the time. But GLiNER as a technique and as sort of an idea to keep in the back of your mind, definitely keep it in the back of your mind. I've had a lot of fun with it.
Really cool tool. And just like a heads up, Vincent, like 2-3 minutes for rounding up for you personally.
Yeah, no, so I was looking at the time and I was already kind of like, okay, I think we're at time. So this would be a great time. Like, are there any questions? Because I'm going to give it back to the host, I think. But yeah, I hope we didn't just talk about spaCy. I hope this is like a general, hey, here's some tools in NLP land that might be useful. Yeah, I do still use spaCy on a, when I'm doing NLP stuff, there's usually some part of the whole system that uses spaCy still, definitely. Even though LLMs are fun to play with, I don't see me not using spaCy anytime soon. Just like it's kind of like scikit-learn. It's kind of like the scikit-learn for NLP stuff in a way. But yeah, having said that, everyone, thanks for listening, and I will now give it back to the host.
Yes, thanks, Vincent. I just want to say as well, like spaCy in my toolbox, it has its own place, its own place.
Yeah, and it also helps that they've got pretty cool stickers. Like that's also something that definitely does help.
Yeah, and I guess if you're attended the previous PyDate Amsterdam, they has a lot of, and I guess with upcoming PyDate Amsterdam in September again, probably we'll see them again as well. I mean, folks from Explosion, right? Well, we don't know yet.
Yeah, so I haven't spoken to Matt and Enos. I don't know if they're attending. I definitely will, but they have been doing conferences again. Like I've had a look at their Twitter and stuff. Like they are doing things again, is my impression.
Okay, I guess for now we're gonna like quickly summarize because we have we need to stop in 5 minutes. We just want to give some probably basic updates of what's coming next, and then I guess we can get back to Vincent if he wants to share anything else with our community. Okay, so basically, I guess Julia, floor is yours.
Yeah. Thank you. Also, thank you, Vincent, from my side. Very cool introduction to spaCy. I have a quick announcement to make. On the 25th of June, we will have another PyLadies meetup given by Molly at the office, and we will be talking about LLM agents. So we will be learning about, like not just how we can talk to LLMs, but also how they can independently take over tasks for us, and how we can build an agent basically for ourselves. And yeah, you're of course all very welcome to join us there. Thank you.
Cool. Okay. And then there are more stuff, of course, coming in, but we were going to keep updates closer to the dates, basically. There are also a bunch of conference happening, as we mentioned, PyDate Amsterdam, which going to take place in September. And by the way, I guess, Vincent, it's until 1st or 2nd June when you can still submit call for proposals.
Oh, I have no idea, but either way, one thing I do want to mention is for every year for the last 5 years, if people want me to review their abstract before they send it in, like DM me on social. Last year, 4 out of 5 people that submitted their abstract to me first did get accepted. Just saying. So if you're kind of nervous or you would just like to get feedback before like an actual reviewer sees it, you can just ping me and I'll gladly have a look.
Well, that's cool. And we also have another event which is coming way sooner. Is basically the PyData Eindhoven together with JuliaConf. From what I remember, I guess CFP is already closed because this is going to happen soon. But for the rest, of course, they are open to welcome you.
And
yep.
they have childcare. Just want to mention that they have childcare this year. Make use of it.
Oh, that's really good. That's really good part. I guess that was our biggest issue during our Python open source sprints, because a lot of people we didn't manage to get the childcare, and it was Saturday, which is not our typical day, and that's how we ended up. But anyway, I guess Vincent, the last words for you then.
Yeah, I mean, so okay. I'm gonna sound really, really cheesy, and I'm well aware of it. Hi, I collaborated with Michael to do a Talk Python training thing. Oh, by the way, it's about spaCy. If you're interested in that, do check it out. One thing I also just want to mention, though, is I was talking to Michael about this, and I mentioned I was talking to PyLadies, and he did say, "Oh, Vincent, here's some codes. If people want to just follow this for free, that's also totally possible." So, we're gonna raffle this. We're gonna figure out how. But if you're interested in a free course, send the organizers a ping, and we will figure that out. Similarly, if you are really serious about doing something with NLP and you're looking for like that little nudge to help you get started, I was also talking to Ines, and she also gave me a free license for Prodigy. So if you're interested in this labeling tool, I can also sort of just hook you up. We'll figure that out later because we've got to close up. But talk to the organizers; they will talk to me, and we'll figure this out. But yeah, Talk Python. People, I guess it's cool. The course stuff, stuff. But if you're really interested in the course, just let the orgs know. And especially if you're like, if you don't mind saving some money for good reasons, that's also totally fine. We'll hook you up.
I would say, to make it easier, then if you're interested, get back to us, and then we're going to do raffle in a couple of days. I think it would be much more easier than, the people go all around, just to keep it more straightforward. So just go back.
Could people raise their hand? Oh, God, COVID vibes.
They can.
Yeah.
I do guess we were not so strict with all the rules.
Yeah. Oh, okay. But we'll figure that out. Having said all that, I do want to also thank folks for joining, and thanks for listening.
Yeah. Thank you so much, Vincent, for being here today, sharing the love for spaCy, and also showing us a bunch of other cool stuff. So as we mentioned, reach out to us if you're interested, or in Prodigy, or otherwise in the fantastic course that Vincent created about spaCy and going much more in depth. So today we were just barely scratching the surface. And hope to see you in our next events. So with this one, I'm going to